Welcome back. Problem 4-99. This problem is taken from chapter number 4, Axial Loading, and book name is Mechanics of Material by RC Hibbeler. So statement is the rigid beam is supported by a pin at A and two steel wires having diameter of 4 millimeter. If yield stress for the wire is 530 megapascal and modulus of elasticity for steel wire is 200 gigapascal, determine the intensity of distributed load W that can be placed on the beam and will cause wire EB to yield. What is the displacement of point G for this case? For the calculation, assume the steel is elastic and perfectly plastic. So you can see this is the beam at point A, it is pin supported, and at point B and C there are two steel wires of 4 millimeter diameter that is supporting. There is a distributed load over whole length which is W. So you have to find this W as well as displacement of this point G due to this load. So you have to find this displacement. So let's start with the solution. So what will be the first step? The first step is that if you remove this pin support at point A, so you will be having a reaction force which is equal to RAY, and if you remove it, so there will be a horizontal reaction force RAX. Similarly, if you remove this wire BE, so there will be a vertical reaction of this wire EB on this beam which is FEB, and similarly for CD the vertical reaction force offered by this wire CD will be equal to FCD on the beam. So what we will do is that again you can see there is a distributed load. So this distributed load when converted into a point load, so it will be equal to W, the magnitude, into the length over which it acts. So 400 plus 250 plus 180 is 800 millimeter. So 800 millimeter is 0.8 meter, and the unit will be in Newton per meter. Okay. So what we will do is that we will apply equation of equilibrium, that sum of all moments about point A is equal to 0, and taking the counterclockwise moment as positive. So you can see the moment about point A, the first moment is due to this FEB and perpendicular distance is this 0.4 meter, and this is producing counterclockwise, so it will be positive. So I will write FEB or FBE into 0.4. The second moment is due to this FCD and perpendicular distance is now 0.65 meter, and this is also producing counterclockwise, so it will be positive. So I will write plus FCD into 0.65, and the last moment that is produced due to this W into 0.8 and perpendicular distance is 0.4, and this is producing clockwise, so it will be negative. So I will write minus 0.8 times W into the perpendicular distance is 0.4. So from here what we will get is that 0.4 times FBE plus 0.65 times FCD is equal to 0.32 W. This is your equation number 1. Now we cannot apply any other equilibrium equation because it will not give you our required answer. So what we will do is that we will perform plastic analysis of wires, steel wires. What do you mean by plastic analysis? That the force is producing yield, the force is yield stress, and it is deforming permanently. So what we will assume that both steel wires fail, both steel wires, okay, let me correct it. This is steel wires yields mean it is deforming permanently. So for that we have been given the yield stress is 350 megapascal. So yield is 350 megapascal, and we know that yield stress is equal to yield force divided by area. So for for BE and CD steel wire, the yield forces will be F of BE is equal to F of CD. Because both have the same diameter, we will have this formula sigma y into its area. So you have sigma y, which is 350 megapascal. So 350, 530, sorry, this is not 350, this is 530. Correct it as well, 530. So 530 into 10 raised to power 6 multiply by area. Diameter is given as 4 millimeter or 0.04 meter. So it will be pi by 4 times 0.004 square. That will give you force in BE and force in CD. So when you calculate it, both these forces FBE is equal to FCD will be equal to 6.660 kilonewton. Now you have these forces. Let this is your equation number 2. So put value of FBE and FCD in equation number 1. So this is your equation number 1. You can see this is your equation number 1. So when you put it the value, so you will get this W. I am not going to put it because this is very easy step. So you will get 21.9 into 10 raised to power 3 Newton per meter. Or you can also convert it is equal to 29.1 kilonewton per meter. Now you have this value. So what we are going to do is that we will find the displacement of this point B. Clear? So how we will find this displacement? So let's see that. Let me write first displacement. So as wire EB or BE achieve yield stress, so corresponding yield strain will be this one, and we know that this will be equal to yield stress over modulus of elasticity. So you can just put the value. Yield strain is equal to 530 into 10 raised to power 6 divided by modulus of elasticity is given as 200 gigapascal. So 200 into 10 raised to power 9. So when you solve this, you will get this yield strain will be equal to 0.002650 millimeter per millimeter. Now we have this yield strain. So what we are going to do is that we will find the change in length of this wire BE. So we know that strain is equal to change in length or original length. So for BE wire, clear? So this yield strain in wire EB or BE will be equal to change in length of BE divided by original length of BE. Clear? So we will find change in length of BE, that will be equal to LBE multiplied by yield strain. So what is the length of BE? So let me check. You can see both have length of 800 millimeter, which is equal to 0.8. So 0.8 multiplied by yield strain, which is 0.002650. So when you solve this, you will get change in length of wire BE will be equal to 2.1 20 millimeter. Now we have these values. So again you can see that initially this beam was like this, clear, and due to the loading, this is your point A, this is your point, let's say B, this was your point C, and this is your point G. So due to the loading, the beam will go like this. So this will be the change in length of BE, delta BE. This will be change in length of delta CD, and this will be the change in length of our delta G, displacement of point G. So we know that the distance between A and B was 400 millimeter, or which is 0.4 meter. This distance between B and C was 0.25 meter. And distance from C to G is 0.15 meter. Now, what we'll do is that you can see you have two similar triangles, three similar. One is this one, clear. The second one is this one, clear. So we will take this similar triangle. Let's say this is your 1 and this is your 2. So two similar triangle. The first one is triangle, right angle triangle AB1, and other is triangle AG2. So by taking the ratio of their sides, so if I take AG divided by G2, so if AG divided by G2, that will be equal to AB divided by B1. So what we will get is that AG is totally 0.8, clear. So 0.8 divided by delta G, G2 is delta G, that will be equal to 0.4 divided by delta BE, clear. So from here we will get delta G will be equal to 0.8 divided by 0.4 into delta BE, that is equal to 2 times delta BE. Now what we get is that delta G is equal to 2 times delta BE. So put the value 2 multiplied by delta B is 2.120 millimeter. So you will get delta G will be equal to 4.24 millimeter. And which is the answer of our this question. So this was all about problem 4-99, in which we have been asked to find the distributed load, clear, as well as the displacement of point G. I hope you have enjoyed this video and you have learned from it. Those who are new to my channel, then subscribe it and don't forget to press the bell icon so that you can get notification about my latest videos. If you have any question, you can ask me in comment section. Also share my videos and help me in growing further. Thank you for watching.